Hi, my name is Jacob Casperson, and this presentation is to discuss the design representation of UML, the Unified Modeling Language. To start, I'd like to talk about a bit of the history behind UML. First off, it is a design representation or a design process that is based off other data structure and other object-oriented approaches. It was built specifically actually, to meet the needs of object-oriented programming and was officially created in 1997. A little bit more background behind UML is that as far back as the early 70s, there were object-oriented approaches to design representation. However, in 1994, the Rational Software Corporation, which is part of IBM, which has been a part of IBM since the early 2000s, actually began the creation of a unified modeling language and basically trying to bring something together that everyone could use, kind of have a universal object-oriented language, because of all of the object-oriented programming languages were beginning to become very popular in the 1900s, and they wanted something that could meet the demand design-wise to the programming. And this was made possible by the participation of many leading companies of the time, such as IBM, Oracle, Microsoft, Digital, and HP. So I want to go over a bit of the structures of UML, some of the symbols. It's important to note in UML there are three distinct models. There are structural models, behavioral models, and architectural models. Something to realize in UML is basically everything in UML is described as a graph or a picture or a diagram of some way. So structural models contain diagrams to represent classes, objects, packages, and components, and those types of things. Behavioral models display more activities, interactions, case diagrams, hence the name behavioral. And architectural is mainly just a diagram, the overall framework of the blueprint of the system. Sometimes package diagrams are actually included in the architectural model. So because there are actually too many things in UML to go over, I'm just going to go over some examples. So first of all, here's a structural example, the class diagram. And many of you probably recognize this from a previous class. This is a class diagram of a student. So the student has a name, the student has attributes, operations, and maybe an extra component which may or may not be there. It doesn't have to be there. But the student class has obviously a name, it has a role, and it has a section. And you can see inside the attribute box that there are a few things that help us define what those attributes are. Are they strings? Are they public? Are they private? And what are the attribute names? Same thing with the operations. Operations are generally functions, while attributes are more like variables. A use case diagram, as in this depiction, is depicting a student that is enrolling in courses with the potential help of registrars. Professors input uh, the marks students earn on assignments, and registrars authorize the distribution of transcripts. So you can see the student can do multiple things. They can try to obtain student grants, loans, reimbursed fees, pay fees. They can drop out of school, graduate from school, or attend a whole bunch of different seminars or or things like that. And this would be the example of a behavioral model or use case diagram. Finally, the last symbol I want to show you is more of the architectural package diagram, which is kind of a very high level overall view of what the system in this particular example of the student and how they interact with different with other parts of the system. So here we see a student should be able to manage their fees, they should be able to enroll, they should be able to interact with loans and grants, and those interact with other people, financial administrators, schedulers, and professors. So we kind of went from a very low level, the student class diagram, then we went to more a little bit more higher level of the use case, and now we're seeing the highest level at a package diagram. So hopefully this gives you a little bit better understanding of a bit about UML symbols and how what the UML language looks like. Lots of pictures. So some advantages to UML is it's specifically made for object-oriented programming. This is, as I went over earlier in the history, that because there's so many object-oriented programming languages that were created and being used, that it became necessary to have a more universal design structure for that. And that's what UML exactly is. It's universally used in many companies. Some other examples is it uses lots of pictures, and as I say, a picture says 1,000 words. The UML language is very comprehensive. In other words, there is basically a syntax for almost anything you could imagine. They've somehow integrated it into a picture, so you can actually be very specific with your design using UML. And it's been through the test of time. So it's been around for a while. It's very well respected and used throughout industry. Appropriate to use, pretty straightforward. Use it with object-oriented projects and programs. Some disadvantages to it is it's not useful with non-object-oriented approaches. The whole basis of UML is to use with classes and objects and those types of things. So if you're designing a system in a non-object oriented way, UML isn't going to be very helpful. Lots of pictures and comprehensive I included in advantages, but then they can also be turned into disadvantages sometimes. You can get actually, as I did, got pretty lost with some of just the sheer scope of how many different symbols and how large the language actually is. And sometimes you kind of want something a little more formal than pictures. So it's inappropriate to use, obviously, in any non-object oriented system. And also, sometimes pictures just aren't useful. They can be, but they're not always too useful. For example, in formal specifications, you might need more math equations. to define what you need to do more than a picture. As a design, UML has been very effective, and it is effective. So it was good. That's all I got to say about that. In our project, I think UML could be very applicable. If you haven't seen this mock-up here, this is a mock-up of maybe what our project could look like. The dashboard with different assignment cards, one column for assignments, the other column for grades. In other words, on the left you have uncompleted assignments, on the right you have the completed assignments, and you have these assignment cards. And here's a picture of the assignment card blown up. So we could use UML in an object-oriented approach to write the specifications for our project. I mean, we'd have a card class, and every card class would have a description, a title, a class, a due date. It would have all these attributes that it would have. And then, of course, we could also make a dashboard object which would contain various card objects. So that's how that could be used, and that's my presentation on UML. I hope you enjoyed it.